All right, folks, welcome to Yak Math Videos for your Calculus Chapter 4 Quiz number 2 review video. Today we are brought to you by in-the-house sponsors of Caldi's Coffee, Cliff Bar, Laura Bar, and a special thank you to our continued Litchfield sponsor, Chinatown, and Coffee Espresso. Folks, I don't have the exact questions in front of me, but on number 1, the first of 3 possible related rates question, you are given that the volume is changing by 5. It's going to be a positive 5, right? It's increasing. You're pumping air into the balloon. We need the rate at which the radius is changing, dr dt, when the radius is 10. Okay, so first off, folks, you need to start with the fact that that is the volume of a sphere. All right, so you need to take the derivative of that equation right there. Again, you always need a formula to work with. Take the derivative with respect to v there and r, so it's dv dt. Bring the 3 down from that r, 4/3 pi r, or r squared, then it's, r prime, so dr dt. All right, the 3's would cancel. You have dv dt is equal to 4 pi times r squared times dr dt. You know that dv dt is 5 and that r is 10. All right, do a little simplifying. Divide both sides by 400 pi. 1/80 pi centimeters per minute is the rate at which the radius is changing. All right, take a look here at number 2. All right, so you're given a ladder. It is going towards, all right, we are pushing the ladder towards the wall. Because we're pushing the ladder towards the wall, so towards the wall would be the x, right? Because it's going towards the wall, the distance of x is actually decreasing, so that's why its derivative is a negative 1/4. All right, when we push this ladder against the wall, the y distance is going to go up, okay, until it's straight vertical there. We need dy dt. All right, so first off, that's, we're going to use Pythagorean theorem. And it says after 12 seconds, what's the rate at which we are pushing it up the wall. So after 12 seconds, we've gone 3 feet in the x direction, okay? Now we started 10 feet away, so that's a 10 right there. We started 10 feet away, and if this is going 1/4 of a foot a second, after 12 seconds, we've gone 3 feet to the left. So now it is 7 feet away from the wall. Pythagorean theorem gives us 13.3 for y. We need to know what y is. Now, z is not changing, okay? Z, that is a constant 15-foot ladder the entire time. So when I take the derivative of my Pythagorean theorem here, 2x dx dt plus 2y dy dt plus 2z dz dt, can divide everything by 2. The derivative dz dt is 0, all right? Then I plug in the fact that I'm 7 feet away after 12 seconds. That's, again, the derivative is negative because your x distance is getting smaller. Plus 13.3 dy dt, set equal to 0. Move the 1.75 over and divide it. So divide 1.75 by 13.3. It is going up the wall at 0.13 feet per second. All right. That is one that is definitely fair. And so is number 3. 3 is another ladder question. All right, again, I don't have this right in front of me, but looking at this right here, the ladder is moving away from the wall. Away from the wall means the x distance is getting bigger. All right, so if it slides down the wall, the y distance is getting smaller and the x distance is getting bigger, all right, at 0.6. What are we talking about? We're talking about meters a second, okay? 13-foot ladder we got there. Let's see, either the question said at the point where, yes, when it's 5 feet away, for x, Pythagorean theorem gives me 12, not feet, but 12 meters for y. Okay, that's, we need the rate at which it's sliding down the wall. That's dy dt. It's going to be negative because it's decreasing, and we'll see that when we actually find the derivative as well. All right, again, we know that we can divide everything by 2. Z is not changing. That ladder is constantly 13. The distance between, the wall and or that just that hypotenuse distance is always going to be 13. That's the best way to explain it. Okay, so 5 for x, dx dt is 0.6. That's the rate at which it's moving away. All right. Plus 12 dy dt. All right. 5 times 0.6 is 3. Move that over. Divide by 12. So it's sliding down the wall at 2.5 or 0.25 meters per second. And it's negative because it is sliding down. The y distance is getting smaller. All right, we get to skip 4 and 5. Number 6, 6a, find the critical points of f of x. Take the derivative, set it equal to 0. All right, factor out a 6. When you factor out a 6, it does factor nicely to, and then again, you can divide everything by 6. 0 divided by 6 is just 0. All right, it does factor nicely to give you critical values of a fourth and -7. Guys, for some of you, this is going to be a very quick quiz on Friday, so it's going to be a good time to work on homework. All right, take a look at B. And we have the derivative of natural log is 1 over what's inside here, that parentheses. And then you have to take the derivative of the parentheses, which is 2x plus 4. And that's what you get there. Now remember, a critical value is when f prime of x is 0 or when it's undefined. So you got to look at the denominator. But unfortunately, or unfortunately for you, that denominator of x squared plus 4x plus 14 cannot be 0 because that is inside right there the parentheses of our natural log, and you can't have the natural log of 0. The natural log of 0 is undefined, so it's not in its domain there. So in fact, that denominator of x squared plus 4x plus 14, which is contained right there, can never be 0 because you can't have the natural log of 0. So your only critical value is when the numerator, 2x plus 4, is equal to 0, so -2 is the only critical value. All right, here on C, folks. On C, take the derivative. It would be 3 minus, 7's on the outside, 1 over 8x plus 2, and then you take the derivative of 8x plus 2, which is 8, which cleans up to be this right here, 7 times 1 times 8. Let's move the 56 over 8x plus 2. Call it 3 over 1, cross multiply. You get 25 over 2. Is one critical value. Again, you would normally check, another critical value would normally be when f prime of x is undefined, so this denominator is 0, but this denominator is in what's inside that natural log right there, and that can never be 0 because you can't have the natural log of 0. So same reasoning as in part B. And let's take a look at D. All right, you got to use the product rule here, folks. So the product rule says, we have, we'll call them like, two different terms here. You take the derivative of the first, which is just 1, times the second. Again, that 5 stays there. Okay, really the derivative first, you're going to call us 5x. That would just be 5 times the second plus the first 5x times the derivative of the second. The derivative of e to the x is e to the exponent. Then you take the derivative of the exponent, which would be -2. All right, so 5x times -2 is a -10x. Notice they both have 5e to the x. You can divide both those terms by 5 and e to the 9 minus 2x, I mean. All right, when you do that, you're left with 1 because you divided 5e to the 9 minus 2x by itself, minus 2x. Now, 5e to the 9 minus 2x, e is, 2.71 something, and when you raise it to any power, that's never going to be 0, so that's not going to happen. So your only critical value here is 1/2. The 1 minus 2x equals 0. Okay, and looking right here, I feel bad, but I don't have the last one, so we're going to have to do that one in class. Make sure you pay good attention tomorrow in class for number 7. This is Yak Math Videos, signing out.